ihasmath, and you're going to learn how to sketch exponential graphs with vertical reflections and graphs from practical context. As mentioned before, these transformations are exactly the same as the ones we have seen in parabolas, but the features of the graphs are different. So let's get right into it. Just to recap from last time, you start drawing this kind of graph by identifying its asymptote. As the number at the end of the equation is -2, the asymptote here is y is equal to -2. Draw it in with a dashed line. So far we know that the graph has been translated 2 units down, but the +1 in the exponent also tells us that it has been translated 1 unit to the left. This means the special point is now at -1, -1, which represents a translation from the normal point 0, 1. Once we've got that, we multiply the distance from the asymptote by the base 3 when moving each unit to the right and dividing by 3 when moving each unit to the left. We're connecting the points and we're done. Remember the sad parabolas? The ones with the negative sign in front of the x squared? They were the result of a vertical reflection, and the same thing is possible for exponential graphs. As always, let's put in the asymptote at y is equal to 0 first. No number at the very end, so no vertical shift. Then we need to find the special point. It's been shifted 2 units to the right, but because of the negative sign in front, it is now also reflected vertically and ends up at 2, -1. For finding the other points, we need to keep in mind that everything is now reflected on the asymptote. At the end, we connect the points with a smooth curve as always. Okay, this certainly looks different, but you will come across these strange equations when something in the real world is modeled. In these situations, x and y are also often exchanged for other variables. We can observe a few things, like there is no number at the end or with the t, so there is no shift at all. And we would expect the asymptote to be the axis, or m is equal to 0. The 200 in front of the exponential expression represents a vertical stretch, just like the number in front of the x squared did in parabolas. However, we still really don't know how to draw this. Enter plan B. Let's use the calculator. As before, we go to Menu, Table, and enter the right-hand side of the equation. Instead of the t, we use x theta t. As t represents the number of years after setting up the account, we should probably set up the table to find values from t is equal to 0 to 10. Step 1 makes sense because we want a value for each year. We can then transfer the coordinates from the table to the graph and connect the points. Although some people may argue that we shouldn't connect the points, as a bank may pay out the interest once a year only. I suppose that it depends on the bank. Let's not worry too much about this. I know that you would find it hard, if not impossible, to find a bank that pays you 8% at the moment, but that may change at some point. The main takeaways from this video are the following. Firstly, knowing the features of an exponential graph, you can draw graphs with a combination of translations, vertical reflection, and even stretches. Secondly, if you can't, use plan B.